All right, we're going to look at a limiting reactant question. So our first example, let's read this. Methane, CH4, burns in oxygen to give carbon dioxide and water according to the following equation. So here's our combustion reaction. It's already balanced for us. In one experiment, a mixture of 0.25 moles of methane was burned in 1.25 moles of oxygen in a sealed steel vessel. In a limiting reactant question, you'll always be given the amount, whether it's moles or grams, this case moles, of at least two of the reactants, which we only have two here. Okay, then the question is going to ask us, find the limiting reactant, if any, which there is, and calculate the theoretical yield in moles of water. So find out how much water is produced ultimately. So it's a stoichiometry question. We just don't know if we should be using this reactant amount or this. So what we have to do is compare these two and decide if we used up all of the methane, how much oxygen would I need? And then if I used up all the oxygen, how much methane would I need? And then I'm going to base it on the limiting reactant because I can only make as much as what my starting substances allow me to. So if I run out of one, I can't continue to make more water. Okay, so and then in part B, we're going to find anything left over. So that's called the excess reactant. So let's start with A. So I always write down kind of my steps a little bit, and I say we're comparing the reactants. To compare reactants, we need to make sure that the unit is in moles. So I'm just going to say in moles here. Okay, so when we do this, we are in moles, so we can jump right into that step. So we're going to compare the CH4 to 2O2. So we're doing a stoichiometry ratio here again. So a mole ratio. So according to balanced equation, this is our ratio. So it doesn't matter which one I do first. Let's just do the first one that I'm reading here. If I use, if I am given 0.25 moles of methane, so I always use this as my given amount. So if I'm given that, let's put that under methane here. I want to know how much oxygen would I need. Okay, so that's what I'm trying to find. That's my unknown. So we've practiced already the mole ratios. Ultimately, you're cross multiplying. So you would have X equals 0.5. So you're timesing 0.25 by 2. That's how many moles of oxygen we need. So I always say required. It's just some keywords that help me keep things organized when I look back. We're going to do the same step, except we're going to now compare what if we used up all of the oxygen given in the question. So again, given, that amount's going to be helpful. So we're going to have 1 CH4 for every 2 O2. So again, for my balanced equation, I'm doing that same step. But this time I want to know if I used up the 1.25 moles of oxygen. So I put that there. I want to know how much methane would I need. So again, do your cross multiply. In this case, you end up dividing 1.25 by 2. So you get X equals 0.625 moles of CH4 required. And again, writing that in is really going to help later in our question. Okay, based on this now, we are still doing the compare things. We compared them, but how much do I actually have? So I need 0.5 moles of oxygen. So when I go back to what's given in the question and I look at oxygen, I need 0.5, but I'm given 1.25. So that's a good thing. I certainly have enough. I have more than enough. That means that's the excess reactant. So let's write a little bit of that down. Okay, so this is what you're kind of thinking through. So I'm given 1.25 moles of O2. So I have more than enough. Therefore, O2 is excess reactant. Okay, which means that because I said there is one, otherwise it kind of defeats the purpose of our question. This one's probably limiting, but let's look at and be sure and figure out why that would be the case. So in this case, okay, if I was to use up all of the oxygen, I would need 0.625 moles of CH4. But if you look in the question, I'm not given that much. I'm going to run out. So as soon as this is run out, I wouldn't be able to, the reaction wouldn't proceed. Okay, so again, let's write this down. So I'm given 0.25 moles of methane. Okay, so again, that's in the question. So I don't have enough. So I don't have enough. Therefore, CH4 is limiting reactant. Okay, because I run out. I only have 0.25 moles. Once that's gone, even though I have excess oxygen, this reaction will not proceed. So we base how to answer the question to how much water is produced based on the limiting reactant. Okay, so that's what we're going to do. So we're going to complete the question based on the limiting reactant. So we'll say complete question based on limiting reactant. So we'll kind of emphasize that, okay? So let's read that question again. What is it we're finding? What question? So we're finding the limiting reactant. Well, we did that. We now know it's CH4. And calculate the theoretical yield of moles in water. So I want to know that if I am given 0.25 moles of methane, how much water can I produce? Okay, so we're comparing methane and water in our stoic ratios. Everything's still in moles, so we don't have to do any conversions. So 1 methane for every 2 water. Okay, so I'm given 0.25. I want to know how much water. Careful on this step. Okay, you're not using what you calculated here. So many times in our math calculations, when we do things, you'll find an answer, of course, use it right away. That's not the situation here, so be careful of that. Okay, so we do our ratio here. You ultimately times that by 2. 0.5 moles. Now I want the correct number of significant figures, so I want to put in 3 significant figures. So that's how much water, so moles of water produced. Now in this particular example, it says to leave it in moles, so we're just learning kind of the steps for limiting reactant. Okay, let's do part B. It's not as many steps because we've done most of the work for it already. So find the number of moles of excess reactant that remains. Okay, so let's just read back and we can see that O2 is the excess reactant. So maybe let's just identify that. So O2 is excess reactant. Okay, so I want to know, well, how much was I given and how much did I actually need? So that's where these keywords are going to come into play. So given's in the question. I was given 1.25, okay, but I only needed 0.5 moles. See how it says 0.5 moles of oxygen are required? So that's how much I used up. So anything else is excess. It's like the leftovers, okay? So I'm just going to move the camera a little bit. We can't see the question as clearly, but okay, so we're going to compare. I kind of write it like with the words. So what's given is 1.25 moles. What did we use? We used, that's the required. So required. And I'm going to subtract 0.5 moles. Okay, so when you subtract that, you're going to get 0.750 with 3 significant figures, moles of oxygen remain. Okay, I always, again, use the keywords here so we have that much remaining. Okay, the previous one, produced, is the keyword that you're going to want to use.